Welcome back for our third day of factoring. All right, actually, I just realized there is a typo on this page. So, can you please change that to a C? I'm sorry for that typo in here, but this is our third day of factoring now. So, looking at this, we're going to deal with special cases of factoring. Now, the first special case is, again, something you saw way back in Expo, something you're really, really good at when you first learn it, because it's super simple. However, it's really easy to forget about the setup. So you need to remember what the setup is. Now, what the setup is, when you only have two terms, they're subtracting, and they're both perfect squares. Okay, those are the three conditions to this whole difference of squares case. All right, so when you have two terms, they're being subtracted and they're perfect squares. Now, what do I mean by perfect squares? Well, I'm talking about 64, 9, 4. All these numbers that I actually listed over here for you to be nice and convenient, those are your perfect squares. All right, and the way to set it up is you always get a plus and a minus because that's what's going to cancel the insides. Then you just plop it in, x and 8, because that's what gives you x squared and 64. Here you set up the plus and the minus. The 3x's give you the 9x squared, and the 2's give you the negative 4. So it's super easy. When I ask you to do it in isolation, you guys are rock stars at it. However, it's when then you have to start doing in the middle of other problems, then you start forgetting it. So again, it's just please remember that setup. Two terms, subtracting, and you're talking about these special numbers. Okay? So let's get some practice with this. So the first one, x squared minus 100. So I know 100 is one of my special numbers. The square root of 100 is 10. And I see that there's only two terms. So right off the bat, I'm going to go like that, the plus and minus. That's kind of my structure for these difference of squares problems. When I notice that's what I'm going to do, when I see I have two terms and I'm subtracting two perfect squares, I know that this is what I'm going to do. To get the x squared is x and x, and to get the negative 100 is 10 and 10, and that's actually it, all right? The problem's done already. You just have to remember that structure, remember that setup. All right, this next one, again, the fact that there's only two terms that are being subtracted, and the numbers are 16 and 49, that's telling me this is going to be another one of those difference of squares. So right away, I put in my plus and minus because I know that's what I'm ultimately going to get. Well, 16x squared. Well, the 16 breaks down into 4's. X squared is going to give me x's, so 4x in this case. Then 49 is 7 times 7. All right, our next one. Again, I see two terms being subtracted, and that 36 draws my attention because I know it's a perfect square. So I start up with my structure, that plus and minus structure. What gives me x squared? Well, x and x. What gives me 36? Well, 6 and 6. Looking at the next one, again, same deal. I see two things being subtracted, and the 25 and the 81 I recognize as perfect squares. So how does 25x squared break down? Well, the 25 breaks down into 5's. The x squared gives me x's. 81 breaks down into 9 and 9. So that's the first technique to remember today, is our difference of squares pattern. Now, there is another technique that I need you to remember. And that is, if there's a GCF, if there's a greatest common factor amongst these numbers, I need you to take care of that right away. Pull that out first. Okay? So, pulling out a GCF. Well, what I'm talking about is, notice, 5, 45, 90. Notice all of those numbers are divisible by 5. So I'm going to pull that 5 out right away. Okay, so that's going to leave me x squared plus 9x, and then 90 divided by 5 leaves me 18. So I pull that 5 out, and now I'm going to factor what's left. Okay, I'm going to factor now the remainder of what's inside that parenthesis. Now I'm back to having a quadratic trinomial, so a 3-termed quadratic. So I look and say, okay, well, x squared, well, that comes from x and x. 18 can break down into these combinations. And now I need those connections to give me a 9x. So when I look at those connections, well, 3x and 6x do give me that 9x squared. Or sorry, not 9x squared, 9x. So that means I'm done. I found it. But the key was you needed to factor out that 5 first. To give a complete factorization, everything needs to be pulled out first if there is a GCF. So in this case, that 5 needs to be pulled out. Now what about this next one? This next one I've included on the list as well. Now the thing that you can pull out this time is not a number per se. I mean, it is, but really it's that negative. So -1 is what I want to pull out, because factoring it out or factoring with negatives with the x squared term gets really, really tricky. So what I'm going to do is I'm going to pull out that negative, which is going to adjust the signs of everything inside. Because picture dividing everything by -1 to rip that negative out of everything, which ultimately just flips the sign of everything. So if you remember to do that, now it's a whole lot easier. So I keep that negative out front. Now I have a quadratic trinomial. So x squared comes from x and x. 8 comes from 1 and 8, or 2 and 4. Now here's that kind of fun case where, notice, I'm multiplying to a positive 8, but I'm combining to a negative 6x. Multiplying to be positive, adding to be negative. We know right off the bat we're dealing with 2 negative values here. We're going to be plugging in 2 negative numbers. So which ones will ultimately give me a -6x in there? Well, here's a -2x, a -4x, boom. That gives us the -6x that we were looking for. All right, so that's when you're just pulling out a number or a negative. There are instances, though, where if there is an x in every term, that comes out with it. All right, so notice this. I have a 3x squared and a -15x. So right away you can probably tell a 3 comes out. 3 divides 3 and 3 divides 15. But notice there's also an x in every term there. So that means an x is going to come along for the ride. An x is going to get pulled out too. So 3x squared. Well, 3 divided by 3 leaves me just 1. X squared, and I'm pulling an x out. So I decrease this exponent by 1. just leaves me with a 1x in there. Negative 15 divided by 3 leaves me 5x, and I'm pulling out the only x there, so no x remains. Then again, you don't have to show that 1x. This is an even cleaner way to show that. But don't forget, you can pull an x out with that GCF. Okay, and now for this one, notice, now what's left in the parenthesis is already linear. Okay, it can't be factored anymore. So for this one, that's actually the end of the story. That's actually it. Done. So let's look at a more interesting case. So on this next one, 15x cubed plus 33x squared plus 6x. Well, let's take a look. So what divides 15, 33, and 6? Well, 3 divides each of those numbers. Okay, so the first thing is see, is there any number that divides everything that's there? And now notice every term has an x in it. So I'm also going to take out an x. And now I'm going to go term by term. So first, 15x cubed divided by 3x squared. Well, 15 divided by 3 leaves me 5. X cubed divided by x, so I'm starting with x cubed, taking away one of those exponents, so that leaves me with an x squared. So 33x squared divided by 3x. Well, 33 divided by 3 is 11. And x squared divided by x, so taking away one of the exponents leaves me just an x. And then 6x divided by 3x. Well, 6 divided by 3 leaves me 2. X divided by x, so the only x is taken away, so the 2 is just left there by itself. So once you've pulled that out, now we can factor that remaining piece, because now we have a quadratic trinomial left in the middle, like left in the parenthesis. So now I'm going to factor it. 5x squared. Well, the only way to get that is a 5x and an x. Then 2, well, the only combination is 1 and 2. So let's plop it in, see if we can get 11x. So here's 1x, 10x, and yes, 1 and 10 does give me that 11x that I'm looking for, so I know that that's the end. I know that that's my answer. All right, so again, today, 2 special cases. We talked about difference of squares, and we talked about pulling out a GCF first and then factoring. So what I'd like you to do, please, is now that we're done with the notes, please go through and write that summary for me. Then once you're done with that, come back ready to do the practice work in class.